Hi guys, hope you all are doing good. So in a previous video we have learned how to insert a node at any position in a double linked list. So today we will learn another important operation, that is deletion at beginning of a double linked list. So don't worry, this topic is actually very easy. I'm going to explain everything in a step by step. So without any delay, let's begin our today's lecture. So suppose we have a linked list. Suppose our linked list is null. So null. So let me erase it. So it's not actually good. So null, backward 10, forward backward 20, forward backward 30, forward null. So this is the initial double linked list. So now we want to delete the first node. Insertion at beginning means first, right? So we want to delete the first node, that means 10. So after deletion the list becomes, first it's gonna become null, backward 20, forward backward 30, forward null. So this is our final linked list. So how can we do it actually? So let us learn. So imagine there are three students standing in a line. So there are three students. So consider this 10, 20, 30 are students. 10, 20, 30 are the students. So now the first student leaves. So this first student leaves from the line. So the second student automatically becomes first student, right? So this is exactly what happens in a double linked list. So now this 10 got removed. So now 20 will be the first node and the 30 will be the second. So 20 is the first, 20 becomes first student and 30 will become the second student. So how can we do it? So for that we need to create a temporary pointer. So we need to write struct node, struct node, temporary pointer, start temp. So initially temp equal to head. So why temp equal to head? So the temporary pointer stores the address of the first node. So obviously head is the first node. So that's why temp equal to head. So now we need to move the head to the second node. So then it gonna becomes head equal to head of next. Yes, if we want to delete the first node, means obviously second node will become the first node in a double linked list. So now head points to the 20. So let me write here 20. So now we are going to make the new first node previous pointer null. So for that we need to write head previous. So head previous equal to null. So why we have done? So because there is no node before the first node, right? Obviously the first, if the element has, if the double linked list has the first node, obviously the before the first node there will be no nodes. So that's why. So on the next line we are going to, on the step 4 we are going to free the old first node. So our old first node is 10, right? So we are going to free that element. So for that we need to write free temp. So free temp. So this releases the temporary, this releases the memory of the node 10. So this will be delete the memory of 10. So deletion is completed. So this is all about the deletion at the beginning of double linked list. So these are four important lines. So let me tell you. So these are the four important lines. The first one is, let me highlight with yellow color. So these four lines are important. So temp equal to head equal to head of next, previous equal to null, and we are going to free temp. So when we are solving deletion at beginning of double linked list, you need to remember this four lines carefully. So let us dry run it actually. So let us dry run it. So let me change the color. So first, initial original double linked list. So original double linked list 10, forward backward 20, forward backward 30, forward null. So this is a initial double linked list. So temp stores the value null. So initially temp equal to 10. So temp equal to first node. So move head to the 20. So head becomes 20. So make 20 previous pointer null. So 20 previous means head previous. So head previous equal to null. Yes, we have declared null. So now we are going to free the 10 nodes. So for the 20, right, free temp. So free temp. So we are done. So we have successfully in the node. So the final linked list will become null, backward 20, forward backward 30, forward null. Yes, we have done. So deletion at the beginning of double linked list is successfully completed. So now let us see the C code. So I have all written the C code. Let me explain it line by line. So these two lines, these two header files are very important. You all know stdio.h and stdlite. So this is access to printf and scanf function, and this is to access the dynamic memory allocations. And we have created node using struct keyword. Int data, we are declaring int data and struct node with two pointers, next and previous. In the main function, we have created three nodes: head pointer, head node, second node, and third node. And this all three nodes we allocated dynamic memory allocation using malloc function. So we are given data. We are storing the data in this variables. We have these lines are used. We have stored data here. Head equal to head data equal to 10, second data equal to 20, and third data equal to 30. So we have created a temporary pointer here. Initially temp equal to head. We are going to head move the head to the second node. Head becomes the second node. For that we need to write head equal to head of next. So head previous becomes null, and we are going to free the temp. So temp equal to head. That's it. So we are printing. So this while loop is to print the all elements in the double linked list. So finally the output is 20 and 30. So this is the C code of deletion and deletion at beginning of a double linked list. So let me ask you some questions. So why do we use a temporary pointer? Actually, because after moving the head pointer, we still need the old first node to free its memory. So that's why. So why do we set head previous equal to null? So it's because the new first node should not point to the any previous node actually. So now the important question is, what is the time complexity? Can you guess it? So let me give an hint. So for deleting the beginning, so we already know the first node. So we take less time. So can you guess it? What is the time complexity? So the time complexity will be big of 1. Yes, because we no need to traverse a entire linked list. We just need the first node only. So no traverse is needed. So I'm going to give an important note that if the list contains only one node, after deletion the head becomes null. So in real programs, always check whether the list is empty or has only one node before performing any deletion operation. So we have successfully covered deletion at beginning of a double linked list. So today you have learned deletion at beginning in a double linked list. In the next video, we will learn deletion at the end in a double linked list with an easy explanation, complete C program, dry run, and interview questions. So I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. Don't forget to like this video, share with your friends, and don't forget to subscribe to our channel. So thanks for watching, and see you guys in the next lecture.